The protein fragments obtained after proteolysis are determined by where the protease cuts the antibody molecule in relation to the disulfide bonds that link the two heavy chains. These lie in the hinge region between the constant heavy 1 and the constant heavy 2 domains, and papain cleaves the antibody molecule on the amino terminal side of the disulfide bonds. This releases the two arms of the antibody as separate Fab fragments, whereas in the Fc fragment, the carboxy terminal halves of the heavy chains remain linked. Another protease, pepsin, cuts in the same general region of the antibody molecule as papain, but on the carboxy terminal side of the disulfide bonds. This produces a fragment, the FAB'2 fragment, in which the two antigen-binding arms of the antibody molecule remain linked. In this case, the remaining part of the heavy chain is cut into several small fragments. The FAB'2 fragment has exactly the same antigen-binding characteristics as the original antibody, but is unable to interact with any effector molecule. It is thus of potential value in therapeutic applications of antibodies as well as in research into the functional role of the Fc portion. Genetic engineering techniques also now permit the construction of many different antibody-related molecules. One important type is a truncated Fab comprising only the variable domain of a heavy chain linked by a stretch of synthetic peptide to a variable domain of a light chain. This is called single-chain FV, named from fragment variable. FV molecules may become valuable therapeutic agents because of their small size, which allows them to penetrate tissues readily. They can be coupled to protein toxins to yield immunotoxins with potential application. For example, in tumor therapy in the case of an FV specific for a tumor antigen. Have a great day.